So today we're going to talk about how to prove a quadrilateral is either a trapezoid or an isosceles trapezoid using coordinate geometry. So the first one that we're going to discuss is a trapezoid. So the first thing we want to go over is the properties of a trapezoid. If you're not sure what they are, how about we graph the picture first? So if I take 2, 0, 10, 2, 6, 7, and 2, 6. That's A, B, C, and D. So, a couple of memories when you learned about shapes. If you notice that this is a trapezoid, hopefully you realize that a trapezoid property is only one pair of opposite sides are parallel. So now, in order to do that proof, how do we show something's parallel? We show parallel using slope. So my plan here is I will use 4 slope formulas to show only one pair of opposite sides are parallel. So now we have to go back to our slope formula. Hopefully you remember that slope is the change in y over the change in x. So I want to show that only one pair of opposite sides are parallel and the other are not. So I have to do 4 slopes. So I'm going to do the slope of AB, BC, CD, and DA. I'm going to hit pause for a moment while I write this down. I'd like you to hit pause on the video and see if you can get your work done as well. Okay, so I did my 4 slope formulas, and if I look at what I got, this one came out to a 4th, this one came out to 1/4. Hopefully you remember that if 2 things have the same slope, they're parallel. This slope here is 5/4, and this slope here is undefined. That means that they are not parallel or perpendicular. So that shows that I have a trapezoid. So now again, we have to write a conclusion to explain what our work, the 4 slopes, show. So you're going to write, since the slope of AB and CD are both 1/4, those opposite sides are parallel. Since the slope of BC is 5/4 and DA is undefined, those opposite sides are not, important, not parallel. A quadrilateral with only one pair of opposite sides parallel is a trapezoid. Therefore, A, B, C, D is a trapezoid. So again, that's using the slope formula to show that we have one pair of parallel sides, one pair of opposite sides not parallel, so it has to be a trapezoid. Again, a lot of work, but it's not difficult work, it's just a lot of writing. Now the next question here says, prove that JKLM is an isosceles trapezoid. So the first thing we might want to go over is the properties of an isosceles. Think about this word here, isosceles. The most common is an isosceles triangle, and that means two congruent sides. So here, if we're talking about an isosceles trapezoid, that also means we're going to have two congruent sides. So the first property, like our regular trapezoid, is only one pair opposite sides parallel. Another property is the non-parallel sides are congruent. Another property is that our diagonals are congruent. And a third property that we're not going to use right now, but we'll use it later in the course, is that the base angles are congruent. So when we do this proof, we're going to do this, and we do parallel with slope, and we're going to do that the non-parallel sides are congruent, and we do that with distance. So the first thing you might want to do is graph the picture so you can see what you're looking at. So we've got the point 1, 3, negative 1, 1, negative 1, negative 2, and 4, 3. So that is J, K, L, and M. So now we go back to writing a plan. So my plan here, because I'm using 1 and 2, I'm going to write I will use 4 slope formulas to show only one pair of opposite sides are parallel, then 2 distance formulas to show the non-parallel sides are congruent. So the first thing we want to write down is our slope formula. My slope formula is y2 minus y1 over x2 minus x1. The sides that I'm finding the slope are the 4 sides of the trapezoid. So I have JK, KL, LM, and then MJ. I also have to do 2 distance formulas for the non-parallel sides. If I look at my picture, it looks like JK and LM are the parallel, so the non-parallel sides would be KL and JM. And for those two, I'm going to do the distance formula. So again, we write down the distance formula, and I am going to hit pause so that I can do the work. I suggest you do the same to see if you get them all correct. Okay, so I did the work, and now we're going to look at what the work shows. For my slopes, I got JK has a slope of 1 and LM has a slope of 1. That tells me that those 2 sides are parallel. LK and MJ have different slopes. They're not negative reciprocals, so that just tells me that they're not parallel. Then if I look at my distance formulas, since these 2 sides are not parallel, but they're the same length, they're congruent. Now I just have to write that out in sentences. Again, not difficult, just annoying to write. So the first thing we're going to say is since the slopes of JK and LM are both 1. They are parallel. Since the slopes of LK and MJ are not the same, they are not parallel. Since the non-parallel sides, KL and JM, have the same length, and you could write of 3, they are congruent. That shows what the work does. Now you have to say, what kind of shape do you have based on that work? So we're going to say a quadrilateral with only one pair of opposite sides parallel and the non-parallel sides congruent is an isosceles trapezoid. Therefore, JKLM is an isosceles trapezoid. Again, a lot of writing, not necessarily difficult work to do. And if you understand the concept and you proofread your work to make sure when you're talking about slope, you're talking about parallel. When you're talking about distance, you're talking about length. This is an easy way to get points on the Regents exam. If you have any questions, please make sure you email me or ask me next time you see me in class.